4.1, plot points in a coordinate plane. All right, so on our graph, we have different like labels of different things that we're going to write on here. So this axis is called the y-axis. Technically, I should put these little arrows on here, but I don't usually draw these. But this is the x-axis. So the x-axis goes left and right. The y-axis goes up and down. This point here in the middle is called the origin, and it has the points 0, 0. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4.
How many boxes should we get on?
It doesn't matter. We're not like actually plotting anything. We're just writing on this one. So if you're using like graph paper, I don't really need to do what I'm about to do because your boxes do it for you. But if you're going to count by increments other than 1, you would need to do what I'm doing. So at each thing, we would have a label and we would be like 1, 2, 3, 4, so on and so forth all the way down. And then to the left on the x-axis, -1, -2, -3, -4, so on and so forth there. Y-axis going up is positive, so 1, 2, 3, 4. Going down is negative, so -1, -2, so on and so forth going down. So you don't necessarily have to put the little tick marks on here if you're just counting by ones. But if you're counting by something other than ones, you need to do it. Or if you are not using graph paper, then you need to do that. Graph paper will make your life easier. In quadrant 1, or well, let me do this first. Our coordinates, or what we call them, are ordered pairs. It's a parentheses, and it has 2 numbers in it, and so x goes first and then y. So that tells you where that point is going to be on your graph. So in quadrant 1, my points would be, both would be positive because up here it's positive on the x, positive on the y. So they are both positive. Over here in quadrant 2, my x values are negative, so that's going to be a negative, and then my y values are positive. So it's negative, positive. Quadrant 3 down here, x is negative and y is negative, so these are both negative. And then quadrant 4 over here, x is positive, but y is negative, so it'll be positive, negative. So just by being given an ordered pair, you should be able to say where it's going to fall on the graph. Just by looking at the signs of the 2 numbers that are in your ordered pair. All right, so we are going to do an example with a bunch of points, but what I'm going to do is I'm going to do one like graph with everything on it, and then we're just going to fill in the ones that we need. Actually, yeah, that's what I'm going to do. All right, I'm going to copy the graph over from page 209. If you don't want to copy it over, that's fine, but I'm going to put it up here so we can talk about it. So questions 4, 6, 8, 10, and 12. I don't know why I just did it in that color. 1 second. And y'all will do the odd ones, but anyways, is letter B, D, F, H, and K. And then on the graph, they're counting in increments of 1, so I'm just going to put the points on here, and then we're going to state what the coordinates of them are for each one. No. All right, let's see. All right. A, B, C, D, E, F, G, H. There's no I. J, K. Okay. All right. So I'm going to be writing the coordinates for each of these points. And then, like I said, y'all will have the odd ones to do. But I just have the whole graph here for you. So we always do the X coordinate first and then the Y. So for point B, we don't move anywhere on the x-axis. It stays there. So that means my x coordinate is 0. The y coordinate is -1. So that's the point for that one. D, how about this one?
This,
What's the x value?
it's 4, -4, -4.
-4 and then what? +3. So back 4, 1, 2, 3, 4, and then up 3. How about F? 3, 0, because it's on the axis. How about H? Yep, -3, -2, because we went left 3 and down 2. And what about K? Yep, back 1, up 2, so that's -1, +2. Now, this particular set of problems doesn't ask us for it, but because there's not a whole lot of these in here, let's talk about how we would classify if we were asked to describe the location of these points. These just said to give the coordinates of the point, but how would we describe B? So it's not in one of the quadrants specifically. So if it's not on one of the quadrants, the options are either the x-axis, the y-axis, or the origin. So what would...
Y-axis.
Yep. So this one would be the y-axis. How about D? What quadrant or axis is point D in? Yep,
2.
quadrant 2. Now, when I'm doing this, I normally just do Q, and then they do Roman numerals for quadrants. Not really sure why, but that's what they've always used. Yes.
We could do the Roman numerals
It's only 4 of them. It's okay.
You can't make an exception.
Nope.
Why?
Because I said so. And I'm a teacher. All right, what about point F?
X-axis.
Yep.
X.
It's on the x-axis. How about H?
H is in 3.
Yep, quadrant 3. How about K?
2.
Yep. So again, when you're doing these problems, you don't have to put where they are, but there's just only a limited amount of those, so that's why I wanted to do those. All right, the next ones, 14 through 21, say to plot the point and then describe the location of the point. So that's what I just did in red here on this one. You can put all of these, so those are all on one graph. You can do another graph for 14 through 21. So if you want to, like, you know, whatever. Or well, when you do the odd ones, you can put them all on one graph. So for 14 through 21, I'm going to just set up one graph here. I have no idea how big this needs to be. I'm just going to do this. All right, so number 14 is the point 5, 5, and they actually give it a letter. So if they give you a letter like these do, you need to put the letter on the graph, especially since you're doing them all on the one graph so that I can tell what's what. 16 is R, and it's -3, 0. 18 is T, and it's -3, -4. And 20 is V, 1.5, and 4. All right, so let's start out this way. What quadrant or axis is point P on? Yep, quadrant 1. So it's hard, but try to describe to me how to get to.
You move to the right 5, move up.
Yep, right 5, up 5. And then make sure you put the letter on there. How about point R? What quadrant or axis is that on?
X-axis.
Yep, x-axis.
Move to the left 3 times.
Yep, left 3.
And then up 0.
Somebody else tell me where point T is. Just say it.
Oh, you go left 3. Oh, quadrant 3.
Okay, now what?
All right, then you go left 3, and then down 4.
Yep. All right, somebody else tell me where V is. Somebody different. Quadrant 1. How do I do this one?
Move it right. The right 1/2. Not
Yep.
full way, but
Yep, so I'm going to go halfway between 1 and 2, and then what?
4.
And then up 4. Now, obviously, I'm not getting out a ruler to measure that it's exactly halfway. Mine kind of looks like it's leaning toward the right a little bit. But just getting it as a ballpark, right? Not trying to be perfect. So that's all you have to do on those ones. Nice and easy.
Is that it?
On those, there's 4 more problems. All right, the last one say to graph the function with the given domain, identify the range of the function. So what we have to do on ones like this, they're going to give us an equation, y equals -x plus 1, for example. The domain that they're giving me is -2, -1, 0, 1, and 2. So the domain values are x values. So if I want to find the range, what values am I solving for? Y. So I'm finding the range for these given domain values. That means I need to plug in each of these numbers for x and solve for y. So y equals negative times -2 plus 1. So what is that equal to? 3.
Space.
So that goes there. I'm going to put in -1, so y equals negative times -1 plus 1. So what does that equal to?
2.
2. I'm going to plug in 0. So y equals 0 plus 1, which is,
1.
you're seeing a pattern.
0.
Y equals -1 plus 1,
0.
0. And y equals -2 plus 1, -1.
I was so confused.
Hmm?
I was so confused.
I'm plugging in each of these values for x over here, and then just solving each one individually.
How'd you get?
So what's really happening here, these are the range values that I was finding, but essentially what's going on is I'm getting a whole bunch of ordered pairs. So -2, 3 is an ordered pair, -1, 2, 0, 1, 1, 2, or sorry, 1, 0, can't read, and 2, -1. So those are my 5 ordered pairs that I'm going to graph on a graph over here. So I'm just going to do a little small graph over here. All right, so -2, 3, back 2, up 3. -1, 2, back 1, up 2. 0, 1, we stay on the axis, go up 1. Yep, 1, 0, go right 1, don't go up or down. And then 2, -1, we go right 2, down 1. And yes, these do graph a line, but these ones you're just technically plotting a point. You don't actually have to connect them. Now, we haven't learned this yet, but this is called a linear equation. Oh, we haven't really talked about it. You've probably seen it before. That's called a linear equation, so that should be a hint that your points when you plot them on your graph should be a line. If they are not a line, something's wrong. And all of the ones in here are lines, so if yours don't create a line, you'll know something's not right.
Yeah.
All right, I'm going to do one more of these, and then that's it unless y'all have questions. 26, y equals -2/3 x minus 1. The domain is -6, -3, 0, 3, and 6. All right, so I'm going to be finding my range values here for each of these. So I'm going to start out by plugging in -6. So I've got y equals -2/3 times -6 minus 1.
It's 3.
So 3 goes into 6 2 times. Negative and negative becomes positive. So I've got -2 times -2 is +4 minus 1. So it's equal to 3. Now I'm going to plug in -3. So I've got y equals -2/3 times -3 minus 1. 3 and 3 cancel. So I have -2 times -1. So that's a +2 minus 1 is 1. Plug in 0. So y equals -2/3 times 0 minus 1. What's that equal to? Yep. -1. Plug in 3. Y equals -2/3 times 3 minus 1. 3's cancel. I've got -2 minus 1, which is -3. And then lastly, what? Did you ask a question?
Me?
Yeah.
No, I said I was just saying the answer.
Oh. And then the last one, y equals -2/3 times 6 minus 1.
Can we cancel out?
3 goes into 6 2 times. Negative 2 times 2 is?
-4.
Minus 1 is?
-5.
Negative 5. So to get for between each of these, essentially I subtracted 2. Is basically what was happening. So now I need to plot these points. Obviously this graph's a little bigger, so hopefully it will fit over here in my space. Just about. Alright, so I have the point -6, 3. So that means I'm going to go left 6 and up 3. I have the point -3, 1. So I'm going to go left 3, up 1. 0, -1. So we stay on the x-axis, go down 1. Then I have 3, -3. So I'm going to go right 3, down 3. And then over here, I've got 6, -5. So right 6, down 5.
It's a line.
And again, yep, they're a line.
Don't look at me like that.
Bro, it's just no.
All right, any questions on this stuff?
It's kind of easy. Do you think it's easy?
All right, so problems then. We're going to do 3 through 21 odd. Remember, the stuff that's in the same little section with each other, you can do on one shared graph. On numbers 3 through 12, you don't need to copy that graph out of your book. You can just write the numbers of what the points are. But obviously, 14 through 21, those set of problems, you need to just do one graph with all the points on them. Okay, just how I did it, where I did the one graph up here, and I just said underneath each point or beside each point, whatever, what the quadrant is. And then the last two problems are 25 and 27, which will be like the two we just finished up with. But you've got a little over 20 minutes. You should have plenty of time to knock that out.